Hey friend, welcome to Datatastic. I'm Paul, and in today's video I'm going to give you a full guide to working with matrices in R. So let's jump right in. Let's start off by defining what a matrix actually is. So in R, a matrix is a two-dimensional data structure that contains elements of the same data type, and all the data points are arranged in rows and columns. So a matrix in R can be thought of as a mathematical matrix or a grid of values. So let's start off by actually creating some matrices. To do so, we have to use the matrix function and pass a few parameters. First off, the first parameter are the values that we want to store in our matrix. So in this example, I want to store the numbers between 1 and 9, and then I have to specify the number of rows and the number of columns. So in this case, 3 rows and 3 columns. And we can look at the matrix, and you can see we have this two-dimensional grid of values. So the values are right here, and you can see we also have numbers for the rows and for the columns. As you can see, the numbers between 1 and 9 are stored by columns. So we fill up the first column with the numbers of 1, 2, and 3, then the second column 4, 5, 6, and then the third column 7, 8, 9. But very often you want to store the values by row. So you want to have the first row with the numbers 1, 2, and 3, and so on. To do so, that's what we do with the second matrix. So again, we use the matrix function. This time we just use the values 20 to 28, 3 rows, 3 columns, and now we have the parameter by row. And if we set this parameter to true, we can look at the matrix, and you can see we have the values between 20 and 28 stored by row. So when we have matrices, we can perform basic mathematical operations. We can do addition, subtraction, division, and element-wise multiplication. So for addition, we use the plus symbol, the minus, the slash for division, and the star for multiplication. So we can, for example, look at the addition, and so we add the two matrices together and we get a new one. Same goes for subtraction. That's the one for subtraction. So you can see we've got all negative values now. That's the one for division. So you can see we can also store very long decimal numbers in our matrix. And we can perform element-wise multiplication. And that's the matrix we get when we multiply. So let's look at how to transpose a matrix. To do so, we use the t function. Then we pass the matrix. In this example, I always store the new values inside a variable and then I print it. And that's the transposed first matrix. We can also do matrix multiplication. So that's not the element-wise multiplication, but the matrix multiplication following the rules of linear algebra. So we use a percent sign followed by the multiplication symbol, and then again followed by a percent symbol. And that's the result of matrix multiplication. We can also use different row and column operations. So for example, we can get the sums of all the rows. So let's look at matrix 1. We use the rowSums function, and these are the sums for the 3 rows when we add the values together. We can do the same for matrix number 2. And we can also calculate the column sums. So we sum up all the values for each column. And that's what we get for matrix 1 and for matrix 2. But instead of calculating the sum, you could also go ahead and calculate the mean. To do so, you have to use the rowMeans function, pass the matrix. So this gives you the means for all the rows of a matrix. And of course, you can do the same, but for columns. So if you use the colMeans function, you get the mean values for all the columns of your matrix. Okay, so the next point is how you can access elements from your matrix, and let's look at our matrix. Again, I've already showed you that the values are here in the middle and you have those indexes for each row and for each column. And this already shows you how you can access the elements. So, for example, row number 1 starts with 1, then followed by a comma, and then after the comma you write the column. So for example, if you want to access value number 5, that's row number 2, comma, column number 2. So let's actually look at it. For example, right here, we access row number 1, comma, column number 1. So this would give us the number 1. But as I've just shown you, if you want to access element number 5, which is located in row number 2, column number 2, you would have to say 2, 2, and this gives you the value 5. And if you want to access, for example, row number 3, which is this one, and column number 2, then you would get the value 6. But instead of accessing a single value, you can also access a complete row or a column. So if we look up here again, for example, row number 2 is 2, comma, and then you could add the column number, or you could just say 2, comma, without anything else, which is exactly what we do up here. So we say 2, comma, nothing, and this gives us the complete second row. And we could do the same for the column. So if we want to access column number 2, you can see up here it says comma 2. If you also want to access a specific row, you would have to add the row number in front of the comma, but if you don't want to do that, you just say comma 2, and then you get the complete second column. So that's what I do up here. And if I print it, you can see these are the numbers stored in the second column. You can also do matrix concatenation. To do so, you have the cbind and the rbind function. In both cases, you have to pass the two matrices. The cbind function binds the two matrices based on the column. So let's just look at that. You can see up to column number 3, that's the first matrix, and then 4, 5, and 6. These columns represent the second matrix. And so that's how you bind two matrices based on the columns. So the second matrix gets added to the first one by just adding new columns. But you can also use the rbind function, and this one, and the rbind function adds the second matrix to the first matrix by adding new rows. You also have the option to filter matrices. To do so, you can add logical operators inside the brackets. So you could say matrix 1 and then the statement that the values in matrix 1 have to be greater than 5. So if we look at that, you can see we get all the numbers for which the statement above is true. So these are all the values stored in our first matrix that are greater than 5. Or for the second matrix, for example, we could say first of all the matrix name, and then again inside square brackets we write the condition or the statement, in this case matrix 2, so that's our matrix, greater than or equal to 21, and this gives us all the values where the statement is true. And lastly, let's look at how you can work with dimensions when using a matrix. So if you want to get the number of rows of a matrix, you use the nRow function. You then pass the matrix, and in this case we have 3 rows. To get the columns, you use the ncol function, pass the matrix, and you get, of course, 3 rows. If you want to get the number of rows and columns at the same time, you can also use the dim function for dimensions, and this gives you 3 rows and 3 columns. Okay, so that was an overview of how you can work with matrices in the programming language R. I hope this video was helpful. If it was, feel free to like, and if you are interested in more videos about R and RStudio, then feel free to subscribe, and see you in the next video. Bye.